we talk about mathematical concepts and their direct equivalence in programming. You left comments asking for more and even suggested some yourself. So here we go, the second part of our journey to show that some things are actually much more similar than you might think. If you want to watch the first part, the link is in the description. So let's talk math and let's start with your ideas. In mathematics, induction is a method for proving statements about all natural numbers. We want to prove that something is true for starting value, say x, and then show that if it's true for x, it must also be true for x plus 1 and so on. But what if we want to prove something for all rational numbers? Fractions like 3/4 or 17/5. Since every rational number can be written as fraction, where both a and b are natural numbers, we can use a double induction. One loop for the numerator and another for the denominator. In C++, this is elegantly captured with two nested for loops, systematically checking every possible fraction within a range. Second, we have recurrence relations, where each step depends on the previous ones. You suggested the gamma function, but I'm going to use another example as its implementation can get a little beyond the scope of what I'm illustrating here. The Fibonacci sequence, that is a classic one. Each term is the sum of the two preceding terms, and it is written as f of n equals f of n minus 1 plus f of n minus 2. In C++, this is mirrored by a recursive function, a function that calls itself and requires a condition to know when to stop. Recurrence relations are everywhere, in finance to model interest, in biology to describe population growth, and even in the computer graphics, for example, to draw fractals. Thanks for your proposals, and let me add 10 more. The XOR, or exclusive OR operation, is fundamental building block in mathematics and digital electronics. I'm adding it here to note that it might be beneficial for you to first check if the operation you need is not already present in the language of your choice. In C++, for instance, there is no need to explicitly program XOR. You can directly use the caret symbol. XOR is fascinating because it is its own inverse. Applying XOR twice brings you back to where you started. This property is used in cryptography. I actually developed XOR-based encryption using chess game notation as my bachelor thesis. It is also used in erased disk arrays for error correction and even in clever programming tricks like swapping two variables without the temporary variable. Think about how to do it and write it in the comments. Congruence modulo, written as A is congruent to B modulo n, means that A and B leave the same remainder when divided by n. In C++, we check this with the percent sign, known as the modulo operator. Modular arithmetic is everywhere. It's the math behind clock arithmetic. For example, this notation means 15 and 3 have the same remainder when divided by 12. Or in other words, 15 and 3 are the same on a 12-hour clock. Modular arithmetic is also essential in cryptography, like RSA encryption, and in hashing functions for efficient data lookup. In computer graphics, it helps with color palette cycling, among other things. Let's talk about set operations. The intersection of two sets consists of elements they share. In C++, you can use std set intersection to efficiently compute this for sorted containers. It works by taking set A from beginning to end and set B in the same way, comparing their elements as it goes. When it finds one that are present in both sets, it uses an inserter to add them to a new one, which will contain only the intersection. Set intersection is not just a mathematical curiosity. It's used in databases to find common records, in search engines to combine results from multiple search terms, and in computer graphics to determine overlapping regions of shapes. Efficient set operations are crucial for performance, especially in large-scale data processing. We have another set operation, the union. This combines all elements from both sets, automatically removing duplicates. In C++, you can use std set union, similar to the previous example, but to show you an alternative approach, you can also create a union by copying one set and inserting elements from the other. Subset, written as A is subset of B, means every element of A is also in B. In C++, the function std includes check this for sorted containers. You might notice that I mentioned sorted several times already. In programming, we actually really prefer sorted containers when it makes sense. So much so that before performing an operation, sorting might be the very first step. Subset checks are essential, for instance, in permission systems. To grant access to a restricted resource, the system might verify that all groups the user belongs to are a subset of all allowed groups for that resource. The natural numbers, denoted by n, are of course the foundation, 1, 2, 3, and so on. In C++, generating them is as simple as looping from 1 to n. Natural numbers are the building blocks of mathematics used in everything, from counting objects to indexing arrays in programming. We can continue with integers, denoted by z, which extended the natural numbers to include 0 and negative numbers. In C++, you can generate them with a loop again, from -n to n. Integers are essential for representing balances, differences, or coordinates in all directions. Another important concept is cardinality, written as vertical bars around A in this case. It simply means the number of elements in a set. In C++, the size method gives you this instantly for almost everything. Cardinality is crucial for understanding the complexity of algorithms, sizing data structures, and analyzing problems in combinatorics and others. The factorial, written as an exclamation mark, is the product of all positive integers up to n. In C++, it's calculated with a simple loop. Factorials grow incredibly fast. For example, 10 factorial is already over 3 million. They are vital in combinatorics for counting permutations and combinations, even in Taylor series used in scientific computing and graphics. Because factorials get so large, they can quickly exceed the limits of standard data types, leading to interesting challenges in programming. So always be mindful of your data types when working with operations like factorial. Last for today, the logarithm. It answers the question, to what power we must raise b to get x. In C++ and other languages, we often use natural logarithm and change the base using the formula logarithm base b of x equals natural logarithm x divided by natural logarithm b. Logarithms are essential in analyzing algorithms such as binary search with O of log n complexity, in audio engineering for measuring sound intensity in decibels, and in the Richter scale for earthquakes. In computer graphics, logarithms play a key role in tone mapping and exposure adjustment. And there it is for today. Second dose of examples of math and programming, connected together closely than you could guess. Thank you for watching. If you enjoyed this video and want to see more, don't forget to subscribe. See you next time.